CVT hydraulic control. A basic way that the TCM controls the two cone-shaped pulleys, or variators as they're called, of the CVT transmission is by using solenoid valves, similar to the older shift solenoid. However, these solenoid valves work a little different. Almost always, these linear mechanical valves are located on the valve body, with the solenoid attached to the top. There are various schemes being used to do the hydraulic control, but the principle is the same, to direct hydraulic fluid to control the variator cone gap width. The CVT valve body consists of pressure sensors, variator pressure solenoids, torque converter clutch solenoids, and on some CVT transmissions, a unique stepper motor, that controls the pressure differential between the primary and secondary pulley system. When the TCM is satisfied with the gear ratio, and the position of the pulleys, the solenoids either vent or hold the hydraulic pressure. Line pressure from the pump is fed into the secondary or primary pulley, to establish the necessary clamping force on the belt. At some instances, the TCM may want a higher ratio to reduce engine RPM, then the primary and secondary solenoids act on the linear mechanical valves accordingly. This allows line pressure to enter the primary pulley. The additional pressure entering the primary pulley causes the cone halves to squeeze together, causing the belt to ride toward the outer edge of the cone. This in turn simulates a large gear. Once the primary pulley moves enough to satisfy the TCM, the control solenoid valves move into the fluid holding state. The TCM will alter the ratio again, by actuating the opposite solenoid valve, letting the pulleys change width until the desired gear ratio is achieved. The fluid release in the primary pulley is controlled by the primary pressure control solenoid valve, and vice versa. As the solenoid is actuated, the pressure trapped in either pulley can either exhaust, or line pressure can be directed to it to increase the clamping load. This is all controlled by the TCM. Once the change is complete, the solenoid and linear valve combination hold the hydraulic pressure as needed. So, to recollect what we've mentioned, the TCM uses a solenoid and linear valve combination to direct hydraulic pressurized fluid to the CVT pulley system, or the primary driver, and secondary driven pulley cones. By using a combination of pressurizing, venting and holding, the TCM can arrive at the needed gear ratio. Of course, all this is done with the help of speed and pressure sensors, that tell the TCM the operation of the CVT at all times. Later we'll cover the workings of these sensors in greater detail. For now, just keep in mind that the TCM is always controlling the CVT pulley system at all times.